Hello students, it's Mr. Washahi again, and this is just going to be a little tutorial on just how to make division a lot easier. I'm going to call it simplifying division because you're going to notice that it's going to tie into when you simplify a fraction, or better yet, reduce a fraction. So let me give you the first example. Let's say you've got a number like 320 divided by 20. Usually our first instinct is to put it in a long division box and to see, okay, how many times does 20 go into 3? Well, it can't. How many times does it go into 320? Okay, that's fine. That's one way of dividing. However, I like to try my best to do division in my head or to shorten it. So what we're going to do is do it a little differently. This is just a strategy I like to use with dividing large numbers, numbers in the double digits or triple digits. So one thing I do, I'm not going to look at the box for right now. Maybe I'll go back to it later. So let's look. One thing, I first look at my two numbers. I know that 320 is being divided by 20. I first like to think, okay, well, do they have a common factor? Is there a number that goes into both of these? If I put them in fraction form, would we be able to reduce this? And yes, we can, because since they both end in 0, they both could be actually divided by 10. So we could look at it as if we're dividing each number by 10. Alright, well, 320 divided by 10, that's going to be 32. 20 divided by 10, that's going to be, well, just 2. And you start seeing this actually looks a little easier to divide than our first example. But you could actually still keep going. If there's still a common factor, so I'm going to rewrite it as a fraction, 32 over 2. If there's still a common factor that you could divide them by, keep going. That's just going to make the division a lot easier, especially if you're trying to divide in your head. So I want you to look at the example. What's a common factor that 32 and 2 have? Exactly, they're both even numbers, so that means we could divide them both by 2. So if I divide 32 by 2, that's going to be 16. If I divide 2 by 2, that's going to be 1. Well, I mean, we can go ahead and write out our division box, but think about it. How many times does 1 go into 16? Well, 16. And these are all going to be equivalent. They're all equivalent fractions over here, so they will go in the same amount of times. So that just makes it a little easier. That was an easy example. Let me show you one that might be a little tougher. So our next example will be 96 divided by 16. Okay, so 96 on the inside, 16 on the outside. Again, I don't want to count by 16s. I don't want to just estimate how many times a 16 go into 96. So I look at it, put it as a fraction if it helps. What's a common factor that both of those have? Okay, so they're both even. We could both divide them by 2, but I try and think of as big as a factor as I can, because that'll cut out these steps. So we could go with 2. We could divide them each by 2. We could maybe try 3. Well, okay, remember, if you add a number together and it's divisible by 3, then that means the whole number is divisible. So 9 plus 6, that's 15. That's divisible by 3, but 6 plus 1 equals 7. That's not divisible. Okay, so I can't reduce them by 3. Okay, well, let's try 4. 4 definitely goes into 16 because 4 times 4 is 16. And 96, 4 goes into 96 because I know if I divide 9 by 4 twice. Okay, so let's divide them each by 4. So let's get the denominator. So 16 divided by 4, that's going to give us 4. 96 divided by 4, 4 goes into 9 twice with a remainder of 1, and that'll leave 16. 4 goes into 16 4 times. So look at that. Now you've got 24 divided by 4. That makes it so much easier. We could either keep reducing, because they're both even numbers. We could divide them both by 2. So if I divide 4 by 2, that's going to give me 2. If I divide 24 by 2, that's going to give me 12. So 12 divided by 2. And we could keep going, but at one point you're going to get this down where you don't even have to do that anymore. We know that 2 goes into 12 6 times. So that means 16 goes into 96 6 times. And if you feel like you need to multiply them out to check your work, do that. It's always good to check your work. Alright, 6 times 6 is 36. 6 times 1 is 6, plus 3, 96. So that checks out. Alright, so again, we're looking for a common factor. Not all division problems are going to have a common factor, so don't think you could use this strategy, but it's a good way to start off. Alright, let's try another example. This will be our last one before I want you to give it a shot. 306 divided by 18. Alright, again, I don't want to count by 18s. What I do want to do is think, what's a common factor that both 306 and 18 have? Excuse me. Well, they're both even numbers, so we can divide them by 2. But I like to do it in, I like to use as big of a factor as I can. Well, let's see, can we divide them by 3? Well, 6 plus 3 equals 9, so that means I could divide 306 by 3. 8 plus 1 equals 9, that means I could divide that by 3 also. I think we could take it one step further. I could divide them both by 6 because they're both even and divisible by 3. But if you add up the digits of your number, 6 plus 3 equals 9. 8 plus 1 equals 9. And if they could be divisible by 9, that means the whole set of numbers could be divisible by 9. So you could actually divide each one of these by 9 to make it a lot easier. Alright? So, we're going to do that. We know 18 divided by 9 is 2. And then 306, well, I could go in. Okay, 9 times 3 is 27. Subtract 3. 36 divided by 9 is 4. So no remainder. So we know 306 divided by 9 is 34. Okay, and look, that makes the division so much easier. 2 goes into 34 17 times. So that means 18 goes into 306 17 times. Think of these as equivalent fractions. They're proportional. And check your work. You could always do 17 times 18. Okay. 7 times 8, that's going to get you 56. 7 times 1 plus 5 is going to get you 12. Okay, I'm going to put my placeholder 0. 1 times 8 is 8. 1 times 1 is 1. You sum them up. 306. Your goes back to your first number. So this strategy is just something that I like to teach that makes division easier. You're not always going to have to use this. You don't have to use this if you don't want. Some people actually like doing division, long division the normal way. This is just a strategy. It makes dividing numbers in your head a lot easier. It helps out with reducing fractions. It even in a way helps you out with your multiplication as well. So whenever you get a long division problem, think, can I simplify them before I divide? Can I make the division a lot easier? Okay, and that lessens the chance of error, and sometimes it might, after a while, it might help you go a little quicker. But it's just a strategy I like to teach. So feel free to use this. Try it on some of your practice problems. And again, don't forget to check your work by multiplying your answer to your original divisor. Alright guys, good luck.